Welcome students. In today's video we will learn about the chapter 5 Augmented Virtual Reality. In this chapter you will learn about these topics: Introduction to AR and VR, difference between AI and VR, use of AR in daily lives, computer vision, applications of computer vision. Now we will discuss our first topic: Introduction to AR and VR. Two exciting concepts in technology are changing how we experience the world: augmented reality, AR, and virtual reality, VR. These technologies allow us to see and interact with digital objects in new ways. In this chapter, we will explore what AR and VR are, how they work, and how they are used in our daily lives. What is augmented reality, AR? Augmented reality, AR, is a technology that overlays digital information, such as images, sounds, or other data, onto the real world. This means you can see and interact with digital objects while being aware of your surroundings. Imagine using your smartphone camera to view your classroom. With AR, you might see virtual animals walking around your classroom or arrows pointing to different objects, providing information about them. The real world is still there, but it's enhanced with these digital additions. Examples of augmented reality, AR games. Games like Pokémon Go use AR to place virtual characters in real-world environments. You can see Pokémon on your phone screen when you play as if they were right before you. AR in education. AR apps can bring textbooks to life by showing 3D models, animations, and additional information when you point your device at a page. AR in shopping. Some apps let you use AR to see how furniture or decorations will look in your home before you buy them. You can point your phone at a spot in your room, and the app will show a virtual version of the item in place. How does augmented reality, AR, work? AR uses a device like a smartphone or tablet camera to capture the real world. Then, it uses software to add digital objects to the scene. This could be anything from a virtual character to a piece of information. The device's screen combines the natural world and digital objects, creating an augmented experience. What is virtual reality, VR? Virtual reality, VR, is a technology that creates a completely immersive digital environment. When you put on a VR headset, you are taken into a virtual world that feels real, even though it's entirely computer-generated. Everything you see and hear in VR is part of this digital world. You can interact with it just like in the real world. When you wear a VR headset, you might find yourself exploring an underwater world, flying through space, or playing inside a video game. In VR, the real world is replaced by this digital environment, and you feel like you're genuinely there. Examples of VR games. In VR games, you can explore virtual worlds, interact with objects, and even feel like you are part of the action. For example, you might play a game where you explore space, fly a spaceship, or fight virtual enemies. VR in education. VR can take virtual field trips to places like ancient Egypt or outer space. You can explore these environments as if you were there. VR in training. Professionals like pilots, doctors, and firefighters use VR to practice their skills in a safe, controlled environment. For example, a pilot can practice flying in a virtual aeroplane before taking off in a real one. How VR works. VR uses a headset with screens in front of your eyes to create the illusion of being in a different place. The headset tracks your head movements, so when you look around, the virtual environment moves with you, making it feel like you are there. VR can also use hand controllers to let you interact with virtual objects, like picking up a ball or opening a virtual door. AR and VR are becoming more popular in games, education, and even shopping, making these activities more fun and interactive. While AR adds to the real world, VR creates a new world to explore. The history and evolution of AR and VR. Understanding AR and VR technologies' origins and evolution over time is essential for fully appreciating them. Early beginnings. Stereoscopic viewers. 1838, creating a three-dimensional, 3D experience began in the 19th century with the invention of stereoscopic viewers. These devices used to slightly different images viewed through lenses to create a 3D effect, which laid the groundwork for future virtual experiences. The Sensorama, 1960 to Morton Heilig invented the Sensorama, one of the earliest attempts at creating a virtual reality experience. The Sensorama machine combined 3D video with smells, vibrations, and sounds to create an immersive experience. Although it wasn't interactive, it was a precursor to modern VR, development of AR and VR technologies, virtual reality in the 1960s and 70s. The idea of VR started to take shape with the development of the first head-mounted displays, HMDs, in the 1960s. A computer scientist, Ivan Sutherland, created the Sword of Damocles, the first HMD that displayed basic computer graphics. However, it was heavy and required a lot of equipment to operate. Early augmented reality, 1990s. Tom Caudell coined the term augmented reality in the 1990s while working at Boeing. He used AR to help workers visualize how to assemble aircraft parts by overlaying digital instructions onto real-world components. Gaming and consumer interest, 1990s. The 1990s saw the first commercial attempts to bring VR to consumers, particularly in gaming. Companies like Sega and Nintendo released VR headsets, but they were limited by the technology of the time, offering low-quality graphics and a poor user experience. Modern advancements, smartphones and AR, 2008-2010 as the introduction of smartphones with advanced cameras, sensors, and processing power enabled the development of AR apps. Apps like Snapchat and Pokémon Go brought AR into the mainstream by allowing users to interact with virtual objects overlaid on the natural world through their phones. Consumer VR, 2010s present. The 2010s saw a resurgence in VR with the development of more affordable and powerful VR headsets like the Oculus Rift, HTC Vive, and PlayStation VR. These devices provided high-quality VR experiences, making the technology more accessible to consumers. Mixed reality, MR. In addition to AR and VR, a new technology called mixed reality, MR, emerged. MR combines elements of both AR and VR, allowing natural and virtual objects to interact with each other in real time. Microsoft's HoloLens is one example of an MR device that overlays holographic images onto the natural world and lets users interact with them. Difference between AI and VR, artificial intelligence, AI, and virtual reality, VR, are essential technologies with different roles and uses. Let's understand the difference between them. You can see the table below. They serve different purposes but can be combined to create even more advanced technologies. The science behind AR and VR. Let's examine the basic science and technology behind AR and VR to understand better how they work. The technology of augmented reality, AR, cameras and sensors. AR relies on cameras and sensors to capture the real-world environment. The camera on your smartphone or tablet acts as the AR system's eyes, capturing everything around you. Processing power. Once the real-world environment is captured, the device's processor analyzes the data to identify surfaces, objects, and the context in which digital elements should be placed. This analysis happens in real time, so the digital elements appear instantly on your screen. Graphics and display. The device then overlays digital graphics onto the real-world image captured by the camera. These graphics can be anything from simple text to complex 3D models, and they move and change as you move the device, maintaining the illusion that they are part of the real world. Tracking and mapping. AR systems use advanced algorithms to track your movements and the camera's position. This allows digital objects to stay in place relative to the real world, even as you move around. The technology of virtual reality, VR headsets. A VR headset is the most important piece of equipment for experiencing VR. It has two small screens inside, one for each eye, that create a 3D image by displaying slightly different views of the virtual environment to each eye, just like how our eyes see the real world. Motion tracking. VR headsets have sensors that track head movements. When you turn your head, the view in the VR world changes just as it would in the real world. Some VR systems also include hand controllers that track hand movement, allowing you to interact with objects in the virtual environment. Sound and haptics. To make VR experiences even more immersive, many VR systems include headphones that provide 3D audio, making sounds come from the right direction as they would in the real world. Some advanced VR systems also use haptic feedback, which means the controllers or other devices vibrate or provide resistance, so you can feel virtual objects. Rendering and simulation. The VR system's processor and graphics card work together to create the virtual environment. This involves rendering 3D graphics, simulating physics, like gravity and collision, and ensuring the experience runs smoothly without lag. Benefits and challenges of AR and VR. While AR and VR offer many exciting possibilities, they also have some challenges. Let's explore both the benefits and the obstacles of these technologies. Benefits of AR and VR. Enhanced learning. AR and VR make learning more engaging and effective by providing interactive and immersive experiences. Students can explore historical sites, conduct virtual experiments, or travel inside the human body. Improved training. VR can be used for safe, risk-free training by professionals in medicine, aviation, and the military. For example, surgeons can practice complex operations in a virtual environment before performing them on actual patients. Creative expression. AR and VR provide new tools for artists, designers, and creators to express their ideas in never-before possible ways. Virtual art galleries, 3D sculptures, and interactive storytelling are just a few examples. Increased accessibility. VR can bring experiences to people who might not otherwise have access to them. For example, students in remote areas can use VR to visit museums or landmarks, and people with disabilities can experience places and activities that might be difficult in the real world. Challenges of AR and VR. Technical limitations. Creating realistic and responsive AR and VR experiences requires advanced technology, which can be expensive and challenging to develop. Additionally, VR systems need powerful computers to run smoothly, which can be costly. Motion sickness. Some people experience motion sickness when using VR, as the brain can become confused by the difference between what the eyes see and what the body feels. This is a common challenge that developers are working to minimize. Privacy concerns. AR systems that use cameras to capture the real world can raise privacy concerns, as they might inadvertently record and store images or videos of people without their consent. Physical safety. Because VR users are immersed in a virtual world, they might not be aware of their physical surroundings, leading to accidents like bumping into furniture or tripping over objects. Ethical issues. As AR and VR become more widespread, ethical questions arise about how these technologies should be used. For example, how should VR content be regulated to prevent misuse, and how can AR ensure it doesn't create a distorted view of reality? Use of AR in daily life. Augmented reality, AR, is a technology that blends the digital world with the real world. It allows us to see and interact with virtual objects as part of our surroundings. Here are some ways AR is used in our daily lives. Education. AR makes learning more fun and interactive. For example, with AR, students can point their tablets at a picture of the solar system and see the planets come to life in 3D, helping them understand concepts better. Shopping. AR helps people shop smarter. Some apps allow you to see how furniture or decorations will look in your home before you buy them. This means you can ensure something fits and looks good before purchasing. Entertainment. Games like Pokemon Go use AR to make the gaming experience more exciting. In these games, digital characters appear in the real world through your phone's camera, making it feel like you're catching Pokemon in your neighborhood. Navigation, AR can help with directions. Some navigation apps use AR to show arrows and signs on your phone screen that guide you to your destination, making it easier to follow directions. Social media, AR is used in social media apps to add fun effects to your photos and videos. Filters that add bunny ears or change your background are examples of AR at work. Ethical and social implications of AR and VR. As AR and VR technologies become more advanced and widespread, it's essential to consider their ethical and social implications. Ethical considerations, privacy concerns. AR devices often rely on cameras and sensors to function, which can raise privacy concerns. For example, if AR glasses constantly record the environment, they could capture images or videos of people without their consent. Data security, AR and VR systems collect large amounts of data about their users, such as their movements, preferences, and interactions. Ensuring this data is secure and used responsibly is a significant ethical challenge. Digital addiction. As AR and VR experiences become more immersive and engaging, there is a risk that people might spend too much time in virtual environments, potentially leading to addiction or a disconnection from the real world. Bias and representation. AR and VR content development needs to consider diversity and inclusivity. If virtual environments are not designed with everyone in mind, they could reinforce stereotypes or exclude certain groups of people. Social implications, impact on social interaction. AR and VR can change how people interact with each other. While these technologies offer new ways to connect, such as virtual meetings and social spaces, they could also reduce face-to-face interactions, leading to potential social isolation. Access and equality. Not everyone can access the latest AR and VR technologies due to cost, availability, or other barriers. Ensuring that these technologies are accessible to all, regardless of socioeconomic status, is essential for promoting equality. Influence on perception. AR and VR can shape how people perceive reality. For example, AR could be used to create convincing advertisements or alter a person's perception of their surroundings. It is important to consider how these technologies might influence beliefs, opinions, and decisions. Computer vision. Computer vision is a branch of artificial intelligence, AI, that enables machines to see and understand the visual world, just like humans do. It's like giving a computer eyes to recognize and interpret images, videos, and other visual information. Imagine you take a picture of your pet dog. With computer vision, AI can analyze the picture and identify a dog, not a cat or a tree. This ability to recognize objects in images and videos makes computer vision so powerful. Application of computer vision, face recognition. Face recognition technology unlocks smartphones and secures devices by recognizing the user's face. The phone's camera captures an image of your face, and AI compares it to stored data to ensure it's you. This technology is also used in social media platforms to automatically tag friends in photos, making it easier to organize and share memories. Healthcare. In healthcare, computer vision helps doctors analyze medical images like X-rays, MRIs, and CT scans. AI can detect patterns and anomalies that might be hard for the human eye, such as early signs of diseases like cancer. This technology aids in faster and more accurate diagnoses, improving patient care and outcomes. Self-driving cars. Computer vision is essential for self-driving cars, allowing them to see the road. The AI in these cars recognizes traffic signs, pedestrians, other vehicles, and obstacles. It helps the car decide when to stop, turn, or slow down, ensuring a safe driving experience without human intervention.